Hello everyone. In this lecture we will talk about water pollution. So when we say water pollution, so it means there is the presence of something harmful in the water. The water could become polluted because of the addition of any chemical in it, because of the addition of any microorganism in it. So water, either it could be fresh water, it means that water which we have in our rivers, lake, or even marine water, that means the water that we have in our oceans. So water could be polluted because of the presence of any foreign body, foreign chemical. So when we say pollution, so it means that it will degrade the quality of water. So water quality, when we say, so it means that the water that we use for drinking, it should not have any color, it should not have any taste, it should not have presence of any solid floating substance, it should not also have any smell. So whenever something additional, some chemical, it adds into the water, so it deteriorates the quality of the water. So we know that when we say water pollution, though we are used to seeing all these water bodies around us. So if you have seen River Yamuna, so during most of the time of the year, you will see that the color of the water is either grayish or even black. During monsoons, if you visit River Yamuna, so you will find that the color of water will be highly muddy. So you cannot find transparent clean water. It is not just about River Yamuna. If you travel to any part of the country, any river that you see, so most of the time you will always find that the water is not up to a very good, it will not have any you will not find that the water is transparent. But if you go to hilly areas, so where the water body where they originates, so there you will find that the water is transparent and clean. Industries are responsible for pollution. Even municipal water that we use and then we just discard as a waste, that is also responsible for pollution. Water pollution, just like air pollution, it can come from the domestic use, it can come from the industrial use of water, it can also come from the agricultural use of water. Just like any solid substance, so we can also generate certain things which could be solid that we enter into the water. So the water that is coming from a washroom contains solid particles. The things that we discard, usually soaps, oils, so all these things that we use in our kitchen, in our washrooms, all these things are also entering into the water bodies. Again, from the industry, the amount of water or the chemicals that reach, they are much more harmful than the chemicals that we release from domestic use. So an industry, for example, a textile industry, which use different types of colors, different types of heavy metals, different types of enzymes to treat fabric, all these things enter into the water. So there are bleaching chemicals, there are chemicals that comes out from the oil refineries, there are chemicals that are coming out of the metallurgy industries. So most of the time it happens, especially in the developing countries, that we do not treat our water. So the treatment facilities that we have, these are limited. So, and most of the times many of these industries are also working like at a very small scale, so they do not have the capacity or the financial uh, like they do not have any proper machineries to treat their water. So most of the times many of these industries are also working in an illegal manner. So because of all these activities, we are facing a huge problem of chemicals that is coming out of the industries. In agricultural sector also, we know that we use a lot of fertilizers. So all these fertilizers that we add on our crops, on our land, so because of the rainfall, because of the movement of water, these things eventually they enter into surrounding water body, and not just surrounding water body, these things also leach or they enter inside ground and then mix with the groundwater. Surface water, you know, it is not easy to clean because we know that we have a huge population. We do not have proper machineries, proper treatment facilities. But groundwater is even harder to treat because first of all you cannot see it, and something which is deep inside ground, so how will you be able to extract it, then clean it, then send it back? So when groundwater contaminates because of any pollutant, so it becomes a major challenge to clean it. Apart from fertilizers, we also put a lot of pesticides in our agricultural fields. So these chemicals, they also become part of aquatic ecosystems, and then these things contaminate the whole area. So when we say pollution, it is also the water quality. It becomes an issue because it will impact the health of the humans. It will impact the health of the organisms, including plants. It will impact the health of the surrounding land. So the quality of soil will also go down. And then that all the economic activities that you do in that area, everything will go down. So water could be polluted on the surface, okay, and because of the things that we already discussed, and it can be polluted within the ground because mostly because of the agricultural usage. So again, there could be a point source of pollution. For example, this is a factory which has a drainage, and then it is putting something in the water body. So here we say that this pollution is a point source because we know the exact location from where the pollutant is entering into the water. But sometimes pollutant could be non-point. For example, an agricultural field. So you have an area which has thousands and thousands of agricultural fields, and so many people are using so many chemicals in it. Because of the rainfall, all the chemicals now entering into different part of the body. For example, in this image, so because of the rainfall, all the chemicals are now entering into from different points into the river. But it will be difficult for you to exactly pinpoint the area from where the chemical is coming because it is coming from a very vast area. So there could be thousands of fields, agricultural fields, and suppose 500 of those agricultural fields are using chemicals, and the water from those fields are entering into the river, but you will not be able to find the exact point of pollution. So that in that case, we have put it under non-point source of pollution. Based on chemical composition, water could be soft. Okay, when we say soft water, it means it has little or no dissolved salts of magnesium and calcium. So magnesium and calcium are the salts or the chemicals that if we have these chemicals more in the water, we say that the water is hard water. If we consume this water, all these chemicals will also enter into our body. No doubt we also need magnesium and calcium because our body require these things are also nutrients. But when we get these things in abundance, so these things tend to like store or accumulate in our body, and then they can also cause problems like stones, kidney stones. So in that case, the water will be hard. Whenever you get water from the municipality, most of the time it will be hard water, but you have RO filtration, aquaguards. So what aquaguards they do, they convert hard water into soft water so that you can consume. Hard water is also not suitable for washing purpose. So if you try to dissolve detergent in hard water, it will not dissolve and it will not form that froth, झाग जिसको हम बोलते हैं. तो उसके लिए you need soft water. So approximately 33% of the pollution it comes from domestic sources. Okay, this is the data that we have in India. 29% comes from agriculture and 27% from industry. It means that all these three factors are somewhat equally contributing in the pollution of water. So when we say domestic, it means the oil, the detergents, the soaps, and the chemicals that we put in water, they most of the time they enter into river directly. These chemicals, although like when we say that soap or detergent, so we have a tendency to assume that these things are maybe not that much harmful, but these things are not natural. So in nature you will not find soap in the water. So whenever we put something like this in the water, so you never know how the organisms, the aquatic the marine organisms will behave. Even our fecal matter, okay? So when we put all these things into the water, so it can also cause different issues because it may contain some bacteria which can cause some disease. There are so many diseases which comes we know that most of the diseases they come from water because of the contaminated water. Another major issue that we are facing recently is the addition of antibiotics. So we eat a lot of antibiotics. We eat antibiotics without even like consulting the doctors. We have a habit of we have a habit to go to a chemist and then buy antibiotics on our own and then consume it. Your body or these chemicals are designed in a way that if you are eating an antibiotic, so your body will retain only 10% of it, and rest of the 90% will be excreted out. And when these antibiotics they enter into the water, so they do something bad. And now people are also talking about this thing, like viruses, they caused a major pandemic. We know that COVID-19. So in future, pandemics can happen because of antibiotics, because antibiotics are designed to kill bacteria which can harm you. But when you put antibiotics in the water, these bacteria are already now uh, in they are being exposed to antibiotics. Let's take this example. You must have seen that all outs, okay? So those liquid all outs. So they used to be very effective earlier. So whenever you used to turn on that machine, so you will find that mosquitoes, like you will not find mosquitoes. But now it happens that even if when you turn on that machine, okay, so you will find that mosquitoes are still around your house. Even sometimes they must be sitting on that machine itself. So it shows that whenever you put a chemical in excess and continuously adding that chemical into the surrounding, these organisms, they learn how to fight. So whenever you put antibiotics into the water, those bacteria will learn how to fight. So what doesn't kill something makes it much stronger. So next time these bacteria will become more stronger, and when they infect you and then you eat antibiotic, it will be of no use. Just like that morphine is now becoming obsolete. It is of no use when it has to kill a mosquito. So this thing happens, all these chemicals are entering from our house, from our homes. Also, we are adding a lot of plastic and other things in addition to this. In agriculture, majorly we are adding a lot of fertilizers, okay, nitrogen, phosphorus, potassium. I will come to that part later, but we are also adding a lot of pesticides. So when we say this thing, like when we use this term pesticide, it means a chemical which is meant to control a pest. A pest is an organism which is harming you or harming the crops and causing an economic loss. A microbe could be a pest, for example, a fungus which has now infected a crop and it is killing the crop, and you are having an economic loss. Suppose I'm growing tomatoes and because of a fungal infection, now that tomato is rotten, so I will not be able to sell it, and it will be a waste of my effort, waste of my time. Uh, a bird could also be a pest. Okay, sometimes wild pigs, boars, they also come and eat all your harvest. That could be a pest. Insects could be a pest. Locust, टिड्डे जिनको हम बोलते हैं, they could be a pest. Even a plant could be a pest. Suppose there are weeds that are growing in your field, and because of that your main crop is not getting sufficient nutrition. So to kill insect we use insecticide. To kill fungus we use fungicide. To kill a plant, a weed, we use herbicides. So all these three are different categories of pesticide. Now we will learn about different classes of pesticide. So we will start with organochlorine. These are the most harmful category of pesticide. So it will have, they are called organochlorines. These are the most hazardous. One example is DDT, dichlorofenylethanes, which we also learned while we were talking about Silent Spring, written by Rachel Carson. Aldrin, Lindane, so endosulfan. Okay, so this is another very important case. It happened in Kerala. So that region of Kerala is called Kasargod, and that area is famous for kaju ki jo farming hoti hai. And you know that in order to sell cashew, you need to put a lot of pesticide because it should be white. Okay, just like an apple which is in perfect shape without any spots will have higher price. In the same manner, a cashew which is white without any spot will have higher price. But to make that cashew white, you will need to put a lot of chemical on that so that insects or fungus and other things, other pests do not attack it. So it has been accepted by the government of Kerala that these farmers or even the authorities were using a lot of endosulfan, and that happened. So for the past a decade, for past 10 to 15 years, they abused they abused the whole area, the whole ecosystem, and they put a lot of chemical on that area. So that chemical entered into different organisms, different part of ecosystems, different food chains, and ultimately it reached to human beings. So now it is accepted by the authorities that a lot of children in that area now they're facing a lot of uh, ailments, physical problems. Many children, they have issues with their limbs, issues with their vision, issues with their cognitive abilities. They have a very lower IQ. Okay, so these things are happening because of one pesticide which we used in a very large number. Then we have organophosphates. So these are less toxic and but they have additive effect. So since they are less toxic, you need to add them more. So if I'm growing some crop and I'm using organophosphate, so I will have to need to add organophosphates again and again and again. So whenever I'm using this pesticide in large quantity, because I have to put it maybe every 15 days. So then it becomes more toxic because the quantity of pesticide is more in the environment. So malathion and parathion are some examples of the organophosphates, and they were also used in wars. So during World War One and even World War Two, so these pesticides were uh, like with the help of helicopters, the enemies, the soldiers, the army used to put this pesticide on the enemies, and then they killed a lot of people also. Third category is organocarbamates. So these are the least toxic. Again, they need to add, we need to add them like in a regular time interval. So one example is Sevin or the Bigon. So all the insect or the mosquito killers that you use, they are mostly organocarbamates. The last category of pesticide is called the biological insecticide. Okay, so usually this is a topic which may not come in the exam, but let me give you a brief idea about it. If you have heard about this term Bt brinjal or Bt cotton, so there is a bacteria which is called Bacillus thuringiensis. This bacteria, it creates a toxin, and that toxin is known to kill some insect. Now we have so much advanced in biotechnology. What we have done, we have taken that particular gene of the bacteria and then used that gene in a plant. We have used it in cotton. So it means the cotton that we are growing, it is genetically modified, and that cotton also has a gene which is coming from a bacteria. So what happens now, that when that cotton grows, so it has a gene that is coming from the bacteria, and that bacteria, we know, that creates a toxin. So suppose there is a caterpillar or some insect which is now on cotton, and that insect is trying to eat the cotton, the leaves of the cotton. So when that insect will eat the leaves of that cotton, so that leaf, when it will enter the insect, inside the insect, so it will create the toxin which was given to that plant by the bacteria, and then it will kill the insect. So here we do not spray any chemical, rather we have made the plant itself a pesticide. So there is a chance that 70% of the cotton that we use in our country, it is Bt, Bacillus thuringiensis cotton. So there is a high chance the cotton fabric that you must be wearing right now could be a Bt cotton. We also made a Bt brinjal. बैंगन को भी हमने सेम चीज करी थी in 2011, but because of the opposition from the public, during that time in India, the government like could not make this something popular, like it could not make this thing a regular thing. So we are not eating anything which is modified, but we are wearing something which is modified. So this is example of a biological insecticide. Then we have industries which are, as we discussed, they cause a lot of pollution. So mining is one of the biggest culprit. Whenever we do mine, so we know that we are taking some metal or something, so we also use a lot of water. So that water, since it is used in metallurgical processes, so that water contains a lot of chemicals. So that is one issue. Cyanide is something which is we use to extract gold. So whenever we are extracting gold, we put cyanide, and you know that cyanide is a very harmful chemical, so it creates a lot of problem in the environment. There is a thing called acid mine drainage. So whenever we keep some mine open, okay, so suppose we have extracted something from this area, now this site is exposed, it is open. Now because of the rainfall, water will accumulate, and then we have learned that in these mines the amount of sulfur is high, and when that sulfur it comes into contact with water, it creates an acid which is sulfuric acid. So these mines, they create pools of acid, and you know that if something acidic is in the environment, it will harm the soil, it will even harm the animals, even plants, and even human beings. These acids, they also like leach, they go inside ground, and they can also meet groundwater. So that is why acid mine drainage is a big problem. Oil refineries, whenever there is some conflict or some accident, so you will find that oil is now, if the oil has leaked in some water body, so it becomes very difficult to like clean that oil. Oil has a lower density than water, so it will always float. It is, the crude oil is black in color, so it will not allow the sunlight to pass through it. So when it will not allow sunlight to pass through it, so it will impact the aquatic photosynthetic organisms. It will impact the diffusion of the air. So air, it will not be able to mix in the water, so the water will have less oxygen, so then it will also kill the animals, fishes, because it creates an area where the oxygen level is quite low. Oil is also combustible, so many times we see that these areas, they catch fire, and then because of that like it also generates a lot of air pollution. Then we have chemicals which is coming out of the textile industries or the leather industries. So these chemicals, they use artificial color. So these colors are something unnatural. Color, obviously it gives a very bad, like you will not bring something which is blue or black or green or red. Okay, so you know that the water becomes contaminated. But it is not just the color that is the problem, but also the chemicals that are being used. These chemicals become part of uh, food chain. These chemicals, they impact organisms, they change their hormones. Okay, and now around 50 to 60% clothes that we wear are made up of plastic. Okay, we use acrylic, polyester. So these plastics, these fibrous plastic material, as you can see in this image, these are also entering into the water. So you can imagine what will happen when these tiny particles, plastic particles, when they will enter into the water, it becomes very difficult to clean them. And that is why the polythenes that we can see, they are still a problem, but we can separate them from the water if we have used certain machineries or certain like we can just pick them from the water. But these threads or microfibers, microplastics, you cannot pick them. So that's why they become a big issue. I suggest that everyone should watch this particular video. So this is a like 7-8 minute video, and then it will give you a very good idea about the level of textile pollution that we are facing in our country. Just like textile, leather is also something which is quite popular. Okay, so whenever we use leather we know that it is the skin of an animal. So whenever we use leather, so what we do, we have to process it because it is organic. It will like degrade over time, but we have to tan it. It is called tanning. For tanning, we use different types of chemicals, even heavy metals, to enhance the sturdiness of that leather. But when we tan the leather, it creates a lot of problem because all these chemicals, they enter into the water body. So Kanpur, Chennai, Kolkata, these are the cities which are known to produce a lot of pollution from the leather industry. And Tirupur, Surat, Panipat, these are known to produce a lot of pollution because of the textile industry. This is a topic which will definitely come in the exam. This is eutrophication. Okay, so there is a high chance that this topic will come. So make sure that you go through this topic properly. You must have seen sometimes the surface water body, it becomes totally green. Either lake, some part of river, some pond, and it becomes green. So again, what it will do, it will, let's first understand what is the reason behind, like why these things become green. So these green thing, these are usually algae, microalgae. Okay, algae is a photosynthetic organism, it has chlorophyll in it, so it becomes green. So but it is not doing something good to the environment. So just because it is green or it is doing photosynthesis, it is creating oxygen, doesn't mean that it is not harmful. In this image you can see this is a lake. Okay, it has turned green, and this is a satellite image. So it means that even from the satellite we can see that a major part of this lake is like, it is like the algae is growing. Surrounding areas we can see that these are all agricultural field. So what happens here, suppose we are using a lot of nitrates or phosphate, these are fertilizers in the fields. Okay, so we have put nitrogen and phosphate to increase the growth of the crops, but because of the rainfall and because of other roots, all these chemicals also enter into water body. So these chemicals are helping plant to grow in the field, but they will also do the same thing when they enter into the water. They will help the plants or the microalgae to grow better in the water. And because of that, the whole water is now covered with microalgae. But this microalgae is causing a serious issue. Whenever there is an excessive growth of microalgae, it is called algal bloom. Okay, so when we say algal bloom, it means that the algae is growing out of control and it has covered the whole water body. So how it will harm? Okay, first thing, it will reduce or decrease the penetration of sunlight. Okay, so when the sunlight will not be able to penetrate deep inside water, so it will not allow the growth of plants that grow at the bottom. Okay, algae will grow on the surface, but the plants that were growing inside the water, they will not grow because they will not get sufficient sunlight. Second thing it will do, when these algae they grow, okay, so pay attention to this part. When algae grow in large number, okay, they also consume a lot of nutrition from the water. Okay, but the problem starts when they start to die. Suppose now algae is growing properly, and after certain time this algae will die. When they will die, they will settle down at the bottom. When they will settle down at the bottom, they will start to decompose. The bacteria in the water will start to eat dead algae. When bacteria decomposes something in the water, they take oxygen from the surrounding. So this algae now, it is dead, it is settling down, and it has reached the bottom of the water body. Bacteria will start to decompose it, and in order to decompose it, they will consume oxygen in the water. And since a lot of algae is dying, a lot of bacteria will start to decompose these algae, and then they will start to use a lot of oxygen. And then there will be a point where there will be no oxygen in this water. And when there will be no oxygen in the water, it will instantly kill the other organisms, like fishes. Fishes require dissolved oxygen in the water to breathe using their gills. But bacterial decomposition is consuming all the oxygen, and because of that, there is no oxygen left for other aquatic organisms, and then they will die. So that is why algal blooms are highly toxic, highly problematic, because they kill fishes and other organisms in a large number. I suggest that you watch this video to get more idea. So Alexandrium, Carinian are the names of certain microalgae which are known to cause algal bloom. Then we have already discussed this thing in previous unit uh, when we were talking about air pollution. This is called bioaccumulation and biomagnification. Okay, I'm quickly going through this topic again. Bioaccumulation means when some chemical it starts to build up in your body and it accumulates or stays in your body. Suppose we are eating certain green plants which are coming from some agricultural field. So we know that like we have to wash those plants properly because these plants contain a lot of chemicals, mostly pesticide. So if we are not washing our plants properly while we are eating those, like suppose fruits or something, we are also eating the pesticide, and then that pesticide will start to build up in your body and it will stay in your body. It will stay in your liver or some other organism or organ, and then after a certain point it will start harming you. So that is what we call as accumulation of chemical inside the body. Biomagnification is something how this chemical is increasing in quantity as we are moving up the food chain. So suppose these are the organisms at different trophic level. These are phytoplanktons, उनको खाने वाले zooplanktons, उनको खाने वाले small fish, उनको खाने वाले big fish, उनको खाने वाली कोई large dolphin or whale or something. You can see that at initial level or the first trophic level, these phytoplanktons are accumulating just 1 unit of the pesticide. Okay. Zooplankton, suppose they are eating 3 phytoplankton, so they will accumulate 3 unit of the pesticide because of their diet. So at this trophic level there is 1 unit of pesticide in 1 phytoplankton. Okay. Then one zooplankton is eating 3 phytoplankton, so they will instantly get 3 unit of pesticide. Suppose is this fish eats 3 zooplankton in a day, so it will get 3 into 3 9 in pesticide. So in the same way the chain goes on and on. As you can see, the organisms which are at the top of the trophic level, so because of their diet, because of the animals they are eating, not only they get nutrition but they also get a lot of pesticide. So the accumulation of a chemical, it increases in an organism as we move up in food chain. This is what we call as biomagnification. Okay, I've already like discussed this thing when I was talking about Silent Spring, written by Rachel Carson, that egg shell wala theory. This is a list of some of the chemicals and what they can do. Okay, so this you have to go through this list. So these are the pollutant, for example mercury, उसके सोर्स ठीक है इंडस्ट्रियल वेस्ट से आते हैं, डेंटल फिलिंग में भी यूज होता है, थर्मोमीटर्स में वी यूज अ लॉट ऑफ मर्करी. It creates an organic substance called methyl mercury, and this is problematic. So these names in red are the major diseases. So mercury causes Minamata disease. It happened in Japan in 1953 and it caused a lot of problem. It caused problem in the muscles, weakness in the muscles, and then it also lead to paralysis and many more things. So go through this like text to know more about what can happen if we come into contact with mercury. Then arsenic, it causes a disease called Blackfoot disease. So the color of the limbs, hands and foot, they become black. So that is why we call it as Blackfoot disease. So it is not just the color that is problematic, but they can also cause a lot of cancer. Cadmium, again we use it in batteries and so many other places. It caused a problem again in Japan called itai itai. Itai itai in Japanese means ouch, ouch. So it like causes a problem with the bones. So if we are getting a lot of cadmium, our bones will become weak, and then when we walk, we will get a lot of pain, just like in arthritis. So uska naam rakh diya itai itai. Then chromium, lead. So just read it. Nitrates, if we have excess of nitrates in the water, it causes a disease called blue baby syndrome, and the color of the skin become blue. Usually babies, like they are more uh, like there's a chance that babies can develop such kind of disease. Methemoglobinemia is another name for this disease. So what I suggest, do remember the name of the pollutant and the name of the disease, okay, and just give a little read. No need to go into detail, but you should be able to link the disease name with the chemicals. There is a chance that this can come in one or two or fill in the blank kind of question. Bacteria, again, as I mentioned, the presence of bacteria, presence of microorganisms, that can also cause a problem. Okay, so let me just give you some idea about this concept of parasite. So we use this term that like this is a parasite or something is a parasite. So parasite is an organism which lives on some other organism. A parasite could be ticks. Just say if you have dogs, so you know that dogs have small insects living on their body. Those insects take their nutrition from the dog because they use the blood. So that tick is a parasite. So many parasites, they live on our body. Lice, जिनको हम जूं बोलते हैं, they also take nutrition from our body because they are consuming blood, and then they grow. So in this kind of relationship, one organism will benefit and the other organism will be in disadvantageous position. A leech could be a parasite because it is taking blood from us, so leech will be in advantage and the human being will be in disadvantage. A lot of worms, they also can be found inside our body, tapeworms. So we eat something, they get nutrition, and then they harm us because they are taking our nutrition, and the growth of the usually most of the children are more exposed to these worms. So this is a parasite. So a parasite could be a protozoa. Okay, it is a single cell organism. Amoebiasis is the name of the disease which is caused by this parasite and Amoeba histolytica. Okay, so you just need to remember one or two names. So it will cause discomfort in the abdomen. It can even cause loss of sight. Bacteria could be a parasite. So botulism is a disease caused by this bacteria, Clostridium botulinum. Okay, it will cause blurred vision, dehydration, difficulty in swallowing, and even speech, diarrhea, vomiting. Dysentery is a very common disease which is caused by Shigella dysenteriasis. Passing of feces with blood. Okay, vomiting of blood. Cholera, again a very well-known common disease caused by a parasite bacteria, Vibrio cholera. Nausea, watery stool, okay, typhoid, E. coli infection are other example. Viruses could also act as parasite. So we know that we have vaccines now against hepatitis A and B. So hepatitis A virus is a parasite which can cause fatigue, fever, nausea, loss of weight, jaundice in human beings. Okay, corona itself, it is a kind of parasite because that virus is entering inside of our body and then it is living at the expense of human being, and then in that process it is also harming that human being. No need to go into detail, just remember one or two example. So this is a question which can usually come, that how water pollution can impact society, can impact social economics or the environment. So just go through these uh, things that I have written here. So suppose a lake is polluted, so it will cause some issues because it will reduce the commercial purpose of that water body. People will not go to that area for fishing. People will not go to that area for recreational work, for boating. People will not use that water for agriculture. It will also reduce the price of the adjacent land. So suppose I am living next to a very polluted lake, so the price of my house will also come down. So it will impact me economically. It will impact recreational activities. Okay, it will also impact the services of the water. Water will not be able to, like, since it is deteriorated, it will also contaminate the surrounding land. Okay, it will also cause problem because now we will have to invest money We will not be able to drink that water. We will have to buy AquaGuard, and then it is an expense. We will go to hospital because we are drinking polluted water, and then we will give a lot of money to the hospital, and it is an expense on poor people. Okay, so just read these like topics. Now, what are the different parameters that we use to measure the pollution in water? So I will quickly go through this. No need to go into detail. So when we try to measure water pollution, what we do, we calculate the BOD, biological oxygen demand. So focus on this topic. So what we do, suppose there are two types of waters. Okay, so I'm just giving you an example. One water, I have two glasses. Okay, in one glass I have collected water from AquaGuard. In another glass I have collected water from some polluted river. Then what I will do, I will use some machine, some instrument to measure the oxygen level of both of these water. Okay, suppose the oxygen level of water A, which is AquaGuard water, it is coming out to be 10 milligram per liter. This is how we measure oxygen. And the water level of the oxygen level of the water that I have collected from a river, polluted river, it is also 10. So both oxygen levels are now 10. Then what I will do, I will cover that water with a lid and then keep that water for 5 days. After 5 days, I will take out both these jars or glass. Again, I will calculate the oxygen level. So in AquaGuard, the oxygen level was earlier 10. Now it will come, suppose 9. So in 5 days, the oxygen level has only dropped by 1 from 10 to 9. But in the water that I have collected from a polluted river, earlier it was 10. Now when I will dip my measuring instrument to calculate the oxygen, it will come out to be 2 or 1. So in 5 days, the oxygen level has dropped from 10 to 1. So now what does this mean? So we will say the biological oxygen demand of river water was more in comparison to AquaGuard water. When I collected water from river, okay, so go back to eutrophication. Okay, what I told you. Suppose that river water contains some pollutant, some organic pollutant. Earlier the oxygen level was 10, but when I kept that water for 5 days, so the bacteria which were present in that water, they started eating the pollution in it or the organic pollutant in the water. So bacteria will eat or degrade or decompose that pollutant. And as I mentioned earlier, when bacteria decompose something, they reduce the oxygen level of the water. So that is why the oxygen level, it dropped from 10 to 1. On the other hand, in AquaGuard water, there is no pollution because the water is already pure. Maybe there are no bacteria also. So in that case, we saw that the oxygen level did not drop from 10 to 1. Rather, it dropped from only 10 to 9. So the biological oxygen demand, the oxygen which was demanded by some biological entity, bacteria, to degrade something was high in river water. So the bacteria that were present in the river water, they demanded more oxygen because there were more pollution in the water, and in order to decompose more pollution, they require more oxygen. So that is why oxygen level dropped down. So if the BOD of the water is high, then the water is highly polluted. If BOD is 1 to 2, just like our AquaGuard water, water is very good. If it is dropping 3 to 5 units, the water is fair or moderate. If it is dropping 6 to 9 units, the water is poor, we should not drink it. And if it is dropping 100 or more, usually sewage water, it is very poor. So this is the biological oxygen demand, okay? But sometimes we do not have 5 days to wait for the result. Okay, we do not have this much time. Sometimes we want result in a second, in a minute. Okay, so in that case we do the same exercise, but rather than waiting for the bacteria to decompose something and consume oxygen, we use a chemical which gives us result instantly. That chemical is potassium dichromate. You don't have to read this in detail, but you should have some idea, just in case this question comes in the exam, so you will be able to write something. Okay, you do not have to be accurate in writing all these processes. You should know the basic concept behind it. So what we do in this process, okay, so I will just explain it briefly. Whenever we add this chemical in the water, potassium dichromate, it reacts with the pollutant, and when it reacts with the pollutant, it consumes oxygen. So if I'm putting, suppose I have again these two types of water, aquaguard and river water. If I put potassium dichromate, there will be very less reaction because there are no pollutant. So the chemical will not demand or consume oxygen in that chemical process because there is no pollutant in the water. But when I put that chemical in the river water, there will be more reaction because there are already some pollutant in the water. And when this chemical will react with that pollutant, it will consume oxygen and it will drop down the oxygen level. So in this case, we get results instantly. Usually the value of COD is much higher than the value of BOD. It can reach up to 1000. So an industrial waste water will have COD of 1000. River water it is usually between 5 to 50. Okay, sewage water will have 500 to 1000. So this is COD. Then we have another parameters also. Okay, so let me just give you idea. So a water which we use for drinking should not have color. So this is a unit called Hazen. It should only have 5 unit of color. Permissal, so these are 2 units. Okay, usually this is the acceptable limit and this is the permissible limit. We want our water to be of this quality, but even if it is of this quality, we accept it, we permit it. So we want that Hazen unit should be 5, but even if it is 15, we allow. We want that the hardness, calcium and magnesium in water should be up to 200, but even if it is 600, we will allow. But there are certain chemicals which should be near acceptable limit. Ammonia in the water should always be 0.5 because if it is more than 0.5, it will harm you. It will harm our internal organs. The pH of the drinking water should be 6.5 to 8.5. Okay, nitrates should not be more than 45 in any case because it will harm you. So the last slide here, not the last slide. So let me just give you a brief idea what happens in the treatment plants where we clean our sewage. So we generate a lot of waste like in our house, okay? And when we generate a lot of waste, so all these things are collected in a drainage. Pipes लगी होती हैं आपके घर के नीचे, and then 100 घर हैं, 100 pipes जुड़ रही हैं एक main pipe से, एक main नाली से, and that pipe is going to some sewage treatment plant. वहाँ पे इनके 2 treatment होते हैं, ठीक है? जो भी पानी आपके घर से जा रहा है, so that water undergoes 2 different types of treatment. The first is primary treatment. Okay, primary treatment में क्या होता है? कुछ filters लगे होते हैं so that all the solid particles could be removed from the liquid water. Okay, so raw sewage आया, it will have certain screens, it will remove all the solid things from it, and then the water will be collected into some chamber. Okay, then we will allow that water to settle down because of the gravity some more solid material will start to, like कीचड़ जमा हो जाएगा नीचे, and then you can collect that कीचड़ or sludge. Then the water will become a little clean, ठीक है, not highly clean. Then we start with the secondary treatment. So कीचड़ निकालने के बाद जो पानी निकला, again it will be colored, it will be black in color or gray in color, it will not be transparent. We send that water into a tank, ठीक है, aeration tank बोलते हैं इनको. So in that tank we keep water for around 1 day or 2 day, and then what we do, we just allow it to settle. The bacteria that are already present in that water, now they will act. They will start to clean the water by decomposing the organic material. Eutrophication में जो पढ़ा, BOD में पढ़ा, same concept will work here. गंदा पानी है, the bacteria will start to act on it. Bacteria जब उसके ऊपर act करेंगे, they will eat all the organic material and then they will clean the water. But do remember in that process वो ऑक्सीजन को कंज्यूम करते हैं. So that is why it is an aeration tank. इसमें हम ऑक्सीजन छोड़ते रहते हैं so that bacteria will always have oxygen to grow and clean the water. Then उसके बाद कुछ कीचड़ और जमा हो जाता है जिसमें dead bacteria भी होते हैं, उसको अलग कर लिया, and then remaining water को we just send it to river. So हमारा जो कीचड़ होता है, first of all we do primary treatment of filtering and screening out things, and then secondary treatment जिसमें bacteria they clean the water naturally, and then the water now which is now clean, उस पानी को आप पी नहीं सकते, उतना clean नहीं होता है, we send that water into the river. Sometimes we take tertiary treatment only in industries, ठीक है, industries में फिर we also need to include third set of treatment where we use certain machines to kill different viruses, different bacteria. We use chlorination. So these are the chemicals that we use, because in industries it is mandatory but it is optional for municipal. So this is how we clean our municipal water. In Delhi, roughly 17 to 20% water is cleaned by this manner, and 80% of the water it directly goes into the river Yamuna without this treatment. So this is a sad state, but it is true. We do not treat our water, clean our water.